Hello guys, welcome back to my channel again. So today I'm going to show you something very simple. I'm going to show you how to convert binary to decimal and decimal to binary. A brief history of decimal is that it's not known when it was started or where it started, but it's believed to have been adopted widely in the early Vedic period between 1200 to 600 BC in India. It was widely used here with these proper rules, arithmetic rules, which was called Ganita, and geometry, which was called Rika Ganita. Now, the Aripatas of the day and ancient Indian mathematicians were using this system here. It was well established. So there's one person by the name Ali Karismi. He's a Persian, was thought to have perfected this. Was born around 780. So you can see it's a very old system, decimal system. The other one is a binary, which was invented by a Germany, Gottfried Wilhelm Leibniz. It was central to his theology, and he believed in this thing of verbal statements, logical verbal statements being turned to mathematical ones. So, in short, binary is about two numbers, which is 0 and 1, and you know what decimal is 0 to 10, 0 to 9, sorry. So we're going to try to convert this into, let's first start with the binary. It's zeros and ones. There's no 2 in binary, so we have like 1 0 0. I have to write and I'll show you 1 1 0 1. For example, this is a number in binary. So we're going to change this number. If I give you this number, maybe it will not make sense to you, but this can make sense to, like in this digital, like a computer can read this and others, but you will not find it easy. So we're going to convert this to decimal, which is easy, and which is a number system that we are using nowadays, widely used, of course. So in order to convert this number, we're going to give it the placeholders, like many counting system of this nature, where we give this to 0, just 1, right? I have to put it this way. I can't write. I'll write and show you. 2 3 4 5 6. So I've written it 0 to 6 up here. The thing we're interested with is this one, but we are going to count from left to right. 0 1 2 3 4 5 6 7. Then in base 2, because binary is in base 2, so we are going to multiply this times 2, starting from here 0. Okay, starting from 0. So we write 2 raised to power 0 times 0, because this is 0. No, sorry, this is 1 raised times 1. Okay, so here, then you come to, let me write and finish, I'll show you. 2 raised to power 1 times 0, 2 raised to power 2 times 1, 2 raised to power 3 times 1, 2 raised to power 4 times 0, 2 raised to power 5 times 0, and 2 raised to power 6 times 1. So here I've written them: 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, to power 3, to power 4, to power 5, to power 6. So we're gonna get the answer. Any number raised to power 0 is 1. So 1 times 1 is 1, so we're gonna give it a value 1. Here 2 raised to power 1 is 2, the second value. 2 raised to power 1 is 2, times 0 is 0. 2 raised to power 2, which comes immediate after this, is 4, times 1. This one is 4. And then we have 2 raised to power 3 is 8, times 1. 8 times 1, this would give us 8. And of course any number multiplied, this one will give us 0 zeros, as you can see, because it's multiplied by 0, although this would give us 16, but we're going to multiply by 0, and this one will give us 32 by 0, and this one will give us 64. 2 times 2 times 2 times 2 times 2, 6 times to give us 64. So we gotten these values. So what we do now, we add them up, and when you add this one up, this is 513. 13 plus this will result to 77 in decimal. So it will give you this value, 77 in decimal. So you have converted 1011,001 in binary to decimal, which has given you 77. Okay, you can see how we started. 1 0 0 1 2 3 4 5 6. So the binary is 2. We start raising it with this value, 2 to 0, 2 to 1, 2 to 3, and all that. We multiply by this. Okay, so I hope you are following. Now that's how you convert binary to decimal. So we are going to convert now decimal to binary. It's very simple. What we do, we take, like now we got 77, which is decimal. The way to convert is to divide it by 2. So you write the remainder. So if you do this 2 divided by 7 is 3. Okay, and 1 is left, 18. 2 to 17, that is 8. So the remainder is 1, because 2 times 38 will be 76. Okay, so now we have 38. I hope you are seeing this, 38. So we are dividing now 38 divided by 2. I have to keep this light in a way so that you can see. I'm sorry, it's not showing properly. So here, this definitely will give you 19, because 19 times 2 is 38. So we're going to have 19 here, and the remainder of this is 0. So we write the 0. So we divide 19 also times 2. We divide by 2. The answer is what? 9, which is 18. 1 is left. So we write the remainder. So we have 9 now. 9 divided by 2. Okay. This will give you 4. 1 is the remainder. Okay. Now divide 4 and divide by 2. This will give you 2. 0 is the remainder. And 2 divided by 2 divided by 2. This will give you 1. Sorry, I have to write this down here. It will give you 1. And then now 1 is left. You cannot divide 1 divided by 2, so you write it down. I have to write it somewhere here. Okay. So we've gotten this. We're gonna write this. I think this will confuse you. It should be down here, 1. You see. So now when we are going to write it back to binary, we start counting from down, not from bottom, not from top. So we write 1 1 0 1 1 0 1. That'll be alright. Yeah, let's see. 1 1 0 1 1 0 1. Are we right? Let's see. The remainder was 1 here. The remainder was 0 here. And the remainder was 1 1 0 1 1. So we got in this value. But I think something is wrong here. Let's try to reconvert this. Let's start over again. I think something looks like something's wrong here. I have to position myself, guys. Let's start again. We have 7 divided by 2. This will go here 3 times. 38. That's 38 times 1 is the remainder. So we have 38 as a value. So we divide this times 2. Divide this over 2. 38 divided by 2. This goes here 1, 9, 19. That means we don't have a remainder here, so we have 0. So once we got 19 here, let me keep cleaning with my hand. Divided by 2. Okay. So this will give you 9 times 2 is 18. 1 is a remainder. So we have 1. And this will give us a value of 9. Okay. So 9 divided by 2. This will give us a 1 will be the remainder. And that will be 8. Divided by 2, that's 4 now. So divide by 4 divided by 2. That will give us 2. And 0 is a remainder. I think you are seeing it now clearly. So now we have 2 divided by 2 is 1. And the remainder is 0. Yeah, this is why we went wrong. So now 1 you cannot divide by 2, so you write it here. Okay, you write it here. So this value is not right. So now to write it back, you write it from down up, not from bottom up, not from like this. 1 0 0 1, which is this one, 0, which is this 0, this one, then 1 1, then 0, which is this and 1. Now this is the correct value. So you have converted 77 back to binary, and you can check it out by putting 0, 1, 2, 3, 4, 5, 6. You can actually ignore the zeros because it's going to give you 0. This one will give you 64 plus this one is to give you 8. 2 times 2 times 2 3 times is 8 plus 2 times 2, it will give you 4. Okay, this is 0 because there's a 0 value. When you multiply number times 0, it will be 0. No, sorry. This is 1. Yeah, this will give you 0, and this will give you 1 because any number raised to 0 will be 1. So this will be 72 plus 476 plus 1 to give you 77. Yeah, sorry, I'm not seeing the light. You are not seeing this. We were checking out whether this value is correct by reconverting again back to decimal, and it is correct. Okay. Now let's come to fractions. What if there's a fraction there? We are going to use the same number with a fraction. So let's write it out. 1001101. Any number is known as. Let's use a very simple number. Let's use 10. We're going to convert these to binary. So add a decimal like 1 0. Let's not use a lot, like 1 1 for example. There's a decimal here, so let's convert this first. We write 0 1. And then here we write -1, -2. Right? So we do the same thing. 2 raised by 0 times 0. 2 raised by 1 times 1. So here we are converting. I've given the simplest number so that you can follow. It doesn't matter the length of the number. So this one is going to give you 0. This is going to give you 2. So the answer is 2. So you see 1 0 is equivalent to 2. Actually there's 2. You see we have 2 in binary, and 10 which I gave you This is a binary. I've given you base 2, so if you convert this, it will give you back 10. So now let's go to the decimal. So decimal is raised to -1, so that will be 2 to -1 times 1. Then you have 2 to -2 times 1. Yeah, so this will give you just the opposite. See, this is a negative number, so this one is going to give you 2 times 1 is -2, and to oppose that one you have to write it this because it's a negative value, and this one is going to give you 4, -4 times 1 is a -4, so it's 1/4 as a fraction because there's a negative value. So now we have 1/2 plus 1/4, right? I don't know whether you are seeing this. What you can do here, these lights. No man. So I have, it will give you 0.5. Okay. Half will give you 0.5, and water will give you 0.25. So when you add these two, it will be 0.7. So I'm sorry, I'm holding it further from the camera. So 0.75. So we'll have 0. Not 0, you don't need to write, you write 7, 5, 7, 5. This is what we 2.75 because it is a decimal we have converted it. There's no difference, you just, because you are at 0 value, so you're going to add -1, -2, then you are going to do exactly the same thing you're doing here. Like you start with 0, 2, because it's base 2, 2 raised to 0, 2 raised to 1. As you give it positional value up here, 0, 1, 2, 3 against the digits. The trouble with this lighting system, I don't know whether you'll see it clear. So I explained, maybe I'll give you a summary of it to make it quite clear. Yeah. So I've told you 10011101 in binary. You're gonna write this starting from 0, 1, 2, 3, 4, 5, 6 up here, and since it's base 2, you are going to take 2 against these placeholders, these things you have put up here. So here is 0 times the value down here is 1, here is 2 to this 1 here, okay, against the value which is 0, as so on and so forth until you reach 2 to 6 times the value down here which is 1. You can see immediately without even doing a lot that you don't need this because this is going to give you 0. Oh, come on. This is going to give you 0. This is going to give you 0 because it's 0 value. So you don't bother with 0 values. You bother with these ones. Let me cycle them. You bother with this one, these values, and this one. This will give you real value, so you can calculate like this. So guys, I hope you understand this, and this is the way you can convert binary to decimal and decimal to binary. So guys, thanks for watching, and maybe I'll do another thing like hexadecimal after this in future. Thanks for now, and share, subscribe, follow, comment. Hope to see you again in the next video. Bye.